Okay, this is the solution to problem number 26. Which of the following statements must be true? Well, let's just kind of go through them and see what makes sense. Choice A says that two parallelograms with congruent corresponding angles are congruent. Well, let's see if we can draw a counter example. Here's two rectangles, which are, of course, parallelograms that are obviously not congruent. However, their corresponding angles are congruent. So this is a counter example to that statement, which means that choice A cannot be our answer. Choice B, two parallelograms with congruent corresponding sides are congruent. So two parallelograms with, if you look at, here's a rhombus and a square. You can put a number on it. Let's say each side of the rhombus is 2 and each side of this square is 2. So this is an example of two parallelograms with congruent corresponding sides, but they themselves are not congruent. So choice B cannot work. Let's take a look at choice C. Two parallelograms whose diagonals are congruent. So here's a parallelogram with congruent diagonals, which means that it is a rectangle. And here's another parallelogram with congruent diagonals. Now I'm drawing those so that they're not congruent, but it does fit the statement here that the diagonals are congruent. So these two are not congruent to each other, so choice C is out. Choice D. Parallelograms are always quadrilaterals, but not always rectangles. Let's think about the first statement. Parallelograms are always quadrilaterals. Well, yeah, that's definitely always true. Parallelogram is defined as a quadrilateral first, and then you get into the parallel sides, opposite sides parallel, and so forth. They might not be a rectangle. In fact, here's one, not a great drawing, but let's suppose this is a parallelogram. Well, it's not a rectangle. Choice D is our answer. Let's look at choice E, just to be certain here. We can roll that out. Parallelograms that are rectangles are not always quadrilaterals. And parallelograms that are rectangles, and that, of course, is false.